Is that better?
Yes. Thank you.
Okay. Welcome. Okay, so quick about me. I'm new to nuttx. I work on a bunch of things that are in software that are unrelated to nuttx. And many of them are written in Rust. That's kind of how I got into this. I'm a Rust library contributor, and I maintain a Rust crate called Rustix, which I'll talk about a little bit later in this talk. And so Ellen reached out to me and said, like, hey, are you interested in like porting Rustix to nuttx, and do you think it would work? And so I said, sure, I'll try it. And this talk is kind of the result of what happened there. So quick digression. Why would you want to run Rust on nuttx? And so the Rust enables developers to build reliable and efficient software. Early on in Rust, a lot of people expected that the main audience for Rust would be programmers coming from C and C++. And one of the things that was a little surprising was that Rust also attracted a lot of developers coming from high-level languages like Python and Ruby. So Rust really helped open up the systems programming language to new audiences of developers. Rust has this property called memory safety, which means that by default in the language, Rust prevents dangling pointers, USF-free, double-free, and many other kinds of like pointer bugs at compile time. So they just can't happen at runtime. Rust does have an unsafe keyword, which means that you do have the full power of raw pointers when you really need it. But the really cool thing about the way this works is that Rust is safe by default. And so when you look at a large Rust code base, you know that all the code is written in this sort of safe Rust subset. And you can quickly find the places that are written using unsafe keyword. And so you can pay more attention to those places very quickly. And beyond memory safety, Rust's expressive type system can enforce many kinds of invariants. This enables library authors to describe their own library invariants in the type system to help their own libraries use their APIs correctly. In total, these properties that Rust has helped attract a community of developers and an ecosystem of libraries and tools that collectively emphasize writing correct programs. So as I jumped in, I took a look at like kind of the existing landscape of Rust on nuttx, and there's kind of two big things that I found. One of them is this very detailed walkthrough of using Rust on nuttx from Luke Yuen, who I believe is presented earlier in this meeting. It's a great walkthrough. It's got a lot of great stuff in it. And one of the things that you can see in this presentation is that there is no official support for nuttx in Rust. And so many of the steps in this presentation end up being fairly low level and kind of rough around the edges. But it's actually a really great kind of background for a place to get started. There's also a Rust Hello World in the official nuttx apps tree. You can see this in the PR that I like to here. And so this works great. But one downside here is that it's using Rust-C directly rather than using Cargo. And so it's not easy to pull in crate dependencies like Rustix or other crates in the Rust ecosystem. So when I started to dive into this further, one of the big things I see when I look at nuttx is that it has these POSIX style APIs. You can see the nuttx documentation online. It has all the file system APIs on the left. It has BSD socket APIs, a screenshot on the right. And beyond that, it has a fairly complete set of POSIX APIs. And it's notable that this is basically the same set of APIs that, for example, the Rust-Edge library is built to work on top of. And so it seems like a lot of things in Rust could work really well on top of nuttx. And so I made what in the Rust world would be the next logical step. When you have a large C API, I created this thing called nuttx-sys. And -sys is kind of convention in the Rust world for crates, which are basically just bindings to existing C APIs, FFI bindings to call out to C code. And so what this roughly looks like is for every function in the nuttx C API, there's a Rust extern C, potentially with a CFG to reflect the Rustix, the nuttx config net. It's kind of translated into the Rust CFG mechanism for conditional compilation. And then we have the receive function, which corresponds to the C receive function in nuttx. We have a file descriptor, a raw pointer, a size of the buffer, a set of flags, and then the return type. nuttx-sys is semi-mechanically derived from nuttx's syscall.csv, libc.csv, and math.csv. These are kind of these existing files in the nuttx tree that describe nuttx's C API. in a CSV form, so it's actually in a fairly declarative form. This is the first thing I tried because I didn't really know what was going on in nuttx. Since I did that, it also occurred to me that nuttx has these header files, has C header files, and so another option would be to run Rust's bindgen tool, which is a tool for generating Rust interfaces from C header files, and just run that over the nuttx's header files. I don't actually know if that would be better, but that would be another option to take instead. Another open question here that I'm interested in if anyone has thoughts about this, I'm sort of interested in catching up with people or answering questions about like how should we handle in binding to other languages nuttx's many config flags. So nuttx has a large set of config flags, which is great for many of nuttx users. And these flags change everything from sort of internal implementation details of how nuttx works to which API is available to, in some cases, what's the actual API of the APIs. So config variables like config SMP NCPUs actually changes the size of some types. So it's not possible to have a single set of C bindings that sort of describes all nuttx configurations. And so one option is to sort of translate the config settings into the Rust bindings so that the Rust bindings are conditional in the same way that nuttx is. Another option would be to say we should have a single set of configs that sort of represent a standard set of configurations to make it easy to have a single C API. I don't know which of those is best, but this is kind of some of the issues that I ran into when I first started looking at it. In any case, I have a thing that seems to work reasonably well for some default settings with these bindings generated from the CSV files. So this nuttx-sys library that I built, which with all these just raw bindings to C APIs, could be the start of a port of Rust's libc crate to nuttx. This actually looks very much like what Rust already uses in its libc crate to bind to existing platform libc libraries. This in turn could be part of the foundation for actually an official port of Rust to nuttx, which I think would be a huge step forward in terms of making Rust usable on nuttx. So I also maintain this library called Rustix, which is a Rust library that specializes in providing safe wrappers around POSIX APIs. So POSIX is an API that's all written in, it's written to be used in C, and so it has a lot of APIs that use raw pointers, raw file descriptors, and function exit statuses, and translate those into idiomatic and safe Rust APIs. Rustix has multiple backends. There's a libc backend to talk to the platform libc and platforms where that's the best thing to use. On Linux, it also has the ability to talk directly to Linux system calls, so it can just bypass libc entirely. And the architecture is such that perhaps it could use other backends in the future. A quick example of what Rustix looked like. I showed that the receive function earlier in that presentation, which is sort of like the raw C, binding to the raw C library. And so with Rustix, you could write a very simple receive function that just takes the socket object, which is some high-level socket type in Rust. It takes a buffer, which would be some kind of memory slice type in Rust. And this receive flags a flag type that's dedicated to be flags, so you can guarantee that you're passing the right type of flags into this function. In Rust, the alternative to using something like this, if you want to call receive directly, is to do a fair amount of ceremony. This example I have here, it requires using an unsafe block because you're calling it to a C library, and by default, Rust doesn't know anything about what C code is going to do, so it considers it to be unsafe. You have to get the raw file descriptor out of the socket, be able to pass that directly. Eventually, you have to cast the raw file descriptor to another type because different platforms receive functions use different types. You have to get the raw pointer out of the buffer and cast that. You have to get the length out of the buffer, eventually cast that because different platforms receive functions take different lengths. And you have to pass this message peak flag, which is his type int, so there's no checking to see that you pass the right flag to the right function. The return value of the receive function is potentially -1 if it's an error, in which case you have to go and check the error no, which Rust has an API to get error no, but error no is kind of this awkward, like separate out-of-band communication thing to get the error message. And otherwise, you can get a successful return. And so Rustix is a library that basically like bundles up all this kind of code and puts it in a very simple API that can typically be inlined to get the same result in your generated code, but it's much easier and much safer to use as a programmer. And so with this, I took Rustix and I took nuttx-sys and added nuttx-sys as a new backend to Rustix in an experimental branch that I have here. using a separate backend within Rustix is actually kind of an interesting thing. Like it was the easiest thing to do right now to get started. But in the future, if there's an official libc port, Rust libc create port to nuttx, this extra backend will become necessary because then Rustix could just use its libc backend to talk directly to these APIs. So this port is highly experimental. It's not really usable yet, but it did kind of get far enough to prove the concept of a lot of these things being possible. And so as I was porting these things, I kind of ran into the kind of issues that I ran into were things like in nuttx, there's no fdatasync function. Fdatasync is simply defined with a preprocessor macro to be equivalent to fsync. And so that's fine. As a platform, you can do that. But C preprocessor macros aren't available to Rust. And so Rust needs to have extra bindings to deal with those things, which we can do. It just takes a small amount of extra porting work. nuttx's struct pool fd has some extra interesting fields that other platforms don't have. And so in Rust, by default, you're not allowed to ignore struct fields. You have to do extra work to opt out of struct fields that you're ignoring. And so this turned out to be a thing we had to port a little bit to. nuttx's UIDT and GIDT are 16-bit instead of 32-bit as they are on many other platforms. And so this is kind of the flavor of the kind of things we ran into when doing the ports. And all these issues are entirely manageable. They're very easy to work with. And it very much feels like if these are the biggest kinds of problems we have while doing the port, then making a full port that actually works properly seems like it's very manageable, very doable, which is very exciting. The hardest part I ran into in all this work is the build system. Trying to work with the nuttx apps and the makefile there, trying to get Rust to work in a form that looks like the makefile is expecting it to look, was quite difficult. And so that's the part that I struggle with. And so if people are interested in working on helping incorporate Rust code and helping build Rust code for nuttx, I'd be interested in seeing what people are interested in. So in conclusion, there's this nuttx-sys library that I built, which could be usable on its own, but it could also be a starting point for porting Rustix, or also for a proper Rust libc create port, which could also be the starting point for a proper Rust target for nuttx. And from what I've seen so far, nuttx's POSIX API looks like it's entirely suitable for porting Rust to Rust standard library, as well as Rustix. And that is my presentation.